All right, guys, so we are in Chapter 9, Linear Inequalities. So in this unit, we are going to be combining some of the work that we've done for the last 2 units in Chapter 6 and Chapter 8, where we looked at patterns and where we looked at solving equations, so the algebra that we've been working on. And we're going to start to incorporate that with inequalities. So just a reminder for inequalities, because you haven't really done these since, I guess, grade 6. So what an inequality is, it's a statement that either compares numbers or expressions that may or may not be equal. I'm not filling these words in for you. You guys can look them up and fill them in, right? Word in a box. You guys do that. So they may or may not be equal. So that's where we use the inequality signs. So just as a refresher for you, these inequality signs, you want to think of it like Pac-Man. And Pac-Man's mouth always goes towards whatever's bigger. Okay? Or some people like to think of it as the arrow. The arrow points to the number that's smaller. Whichever way you remember it, just find a way to remember it. So this sign is saying that A is greater than B. So A is larger, A has a greater value. So keep in mind that this might apply to negative integers as well. So this could be like -1 is greater than -10. Right? It has a greater value because it would be closer to 0. So it could be negatives included. In the second one, B is the larger one that's being eaten. So this is saying that A is less than B. So then maybe we have 7, so 7 is less than 12. I don't know, I'm just making these up. In the third one, we now have an equal sign included below, so that means that A is greater than or equal to B. So that could be that we have A has a value of 5 and B also has a value of 5, because then they could be equal. Or A could be greater, so maybe B has a value of 4. But in these ones, B can't be larger than A still. So I'm going to just kind of rip through the next one. So then this one is A is less than or equal to B. Okay, again, 3 must be, or A must be less, but it could be equal, but it can't go greater. And then this last one we've kind of already used. This is just saying that A cannot be equal to B. So basically what that's saying is if B was 8, A could be anything except for 8. So if B is 8, A could be anything else. Anything but 8. Okay, so just a quick example. So it says many jobs pay people a higher rate for working overtime. This is pretty common unless you're on a salary job. But for your guys' first kind of jobs, you would be working hourly, so you would get overtime. So in this case, Lisa earns overtime when she works more than 40 hours a week, and that's pretty normal. So give 4 possible values that might result in overtime pay. Well, if she works 40.5 hours, that's more. So she would have, if she works that many hours total, 0.5 hours of that would be overtime. If she worked 50 hours, she would have 40 hours of regular pay, and then she would have 10 hours of overtime pay. You can come up with 2 more examples for me for that one. So now it says verbally, so in words, express the amount of time that qualifies for overtime as an inequality. So up to 40 hours, she makes regular pay, and then it's anything over 40, not including 40. So the way that we would say this is any hours over, so greater than 40 hours per week. So then we're going to show it graphically, and noticing that we're only using a number line now instead of a coordinate grid. What's relevant on number line is the 40 hours. We could show other numbers, so maybe we start at 0 hours, so 10, 20, 30. Should be a 30, not a 30. There we go. 40, 50. Okay, so then anything more than 40, so starting at 40 and anything more than 40, and it could go on. You notice how we put the arrow on the end? Now eventually that arrow would have to stop because there's only so many hours in a week, but it could potentially keep going. She could keep earning more for every hour she works over 40. You notice that I didn't color this circle in, that I made it a big empty circle? This is because 40 is not included, and we're going to talk about that kind of in the next set of notes. Just notice that we did that on purpose, okay? So the circle is not colored in. So now we're going to express the inequality algebraically. And so if we're using algebraically, we need to have a variable. So a variable, let's say, is, I don't want to use O for overtime, so let's use H for overtime hours. Okay, and so any hours greater than 40 will give her overtime. We could also put it the other way. We could say 40. Either. Okay, so then we need to represent the amount of time that does not qualify for overtime. So let's call that, I'm going to use R for her regular pay hours. Okay, so her regular pay hours are any of her hours that are less than or equal to 40 hours. Anything up to 40 hours, she makes her regular pay. If anything after that she's not going to make her, she's going to start making her overtime pay, which is bigger. So that is as algebraically. If we're going to say it graphically, we could sketch a number line, or actually, let's go back to the other number line. I'm just going to use it in the other color. So then her regular pay hours would be at 40, and it would go from 0 to 40. So I put a closed dot at both of those because it would include 0 hours, right? 0 times whatever her regular pay, she wouldn't make any money. And it goes all the way up to 40 hours, but it includes her 40 hours. Okay? And then verbally. So verbally we could say she earns regular pay for any hours up to and including 40 hours, let's say, per week. That's probably important. Okay, so graphically, verbally, algebraically. So boundary point, that's another important word that you are going to need to look up and write down. But basically what a boundary point is, if I go back to the other page, is notice how we have one dot that is open and one dot that is closed. So when an inequality does not have an equal sign in it, so it's only greater than, it's not greater than or equal to, the boundary point is not included in the inequality. However, when there is an equal portion to the inequality, so it could be equal to, we do a closed dot. And so the closed dot says that this point is important, that this point can be included. So an open dot at a boundary point says the point can't be included, so it's not, it doesn't include an equal sign in an inequality. the closed dot says it is included, so there is an equal sign part of the inequality. So boundary point, you're going to want to write that down for yourself. Okay, these next examples. So you always start at the boundary point when you need to write an inequality. So when we're looking at the first one, the boundary point is 4. And I know that when yours printed, your numbers kind of shifted a little bit. But anyways, 4 is our boundary point, and we can have any value that is greater than 4. So if the line extends to the right, I'm going to put my variable on the right side. And so that means I can have any values that are greater than 4. The dot is closed at my boundary point. So this tells me that I can have it equal. So 4 is less than or equal to x. Or we could say that x must be greater than or equal to 4, right? And the way we could test that is pick one of those larger values. Is 4 less than or equal to 6? Yes. And is 10 greater than or equal to 4? Yes. Okay? So just picking 2 of those values that fall on our line. Looking at letter B, I know that this one's a little bit light on your papers and in the notes, so I'll go over it with green. There. Crazy on the smartboard that when you put yellow and other colors together, they don't actually change, hey? You notice that? I noticed that. Okay. In this case, our boundary point is -2. And our line goes to the other side, so I'm going to put my variable on the left of my -2. And so this means x must be less than -2, right? Keep in mind, value-wise, the more negative we go, the less the value. And the boundary point is an open circle, so we can't include the equal sign. So it's just x must be less than -2. Or we could say -2 must be greater than x. So notice when we flip them around, the sign flips as well. So just to pick an example, let's say -4 must be less than -2, and that's true. And then let's pick another one. So -2 must be greater than -8, and that's also true. Okay, so that means we've rewritten them the right way. On the last one, so in this one we have 2 boundary points. We have a boundary point at 4, and we have a boundary point at 5. So when this is the case, your variable goes in the middle of your 2 boundary points. Okay, I'm going to bring them close together now, because there's no point in having them that far away. So this means that x must be between 4 and 5. So we write the inequality signs in the same direction. So x must be greater than 4, but x must be less than 5. Now, when we look at both boundary points are closed. So that means both boundary points could also be equal to.
People in the building.
Okay, so I'm going to leave this last example for you. You're going to represent each of the following using different colors. So you probably need pencil crayons. If you don't have different colored pencil crayons, maybe use like a dashed line on one or a darker line on the other, or one above and the other one's below, or something like that. But some way to represent those 3, and I'm going to check those from you tomorrow.